The world of AI is racing ahead. Models with billions of parameters, datasets growing by orders of magnitude, and underneath it all is the hardware, the unseen engine of the intelligence revolution. Meet Cerebras Systems, a company few talk about, yet quietly doing something no one else is doing, building entire wafers of silicon, not dozens of chips, to tackle the most demanding AI workloads on the planet. If you've heard of GPUs and graphics cards powering AI, think again. Cerebras is taking a different path. This story is about why that matters and what it might mean for the future.
This configuration finalizes
Origin
the integration.
story.
The flow dynamics look
Founded
stable.
in 2015
the energy
in
transfer rate is
Sunnyvale,
optimal.
California, Cerebras Systems was created by a team of chip design veterans who believed the path AI needed wasn't incremental, it was radical. Instead of stitching together many small chips, they asked, what if one chip could do what hundreds of GPUs struggle to do? What if you could break the memory and communication bottleneck that GPUs face? The answer, the wafer-scale engine. A wafer-sized processor measuring 8 to 10 inches across, containing trillions of transistors. Designed from the ground up for large-scale AI training and inference. It sounded crazy. The size, the yield risk, the cost. But for them, the risk was worth it. Technology explained traditional AI hardware uses many chips, many sockets, many interconnects. That's slow, power-hungry, and complex. Cerebras took a different route. One giant chip, integrated memory, logic, interconnect on a single wafer. Their WSE2, for example, boasts over 2.6 trillion transistors and hundreds of thousands of cores. That means less latency, higher bandwidth, and faster training or inference of massive models. Deployment shows speed and cost advantages in real-world settings. The message is clear. If you want to build the next generation of generative AI, you'll likely need hardware that isn't just improved. It needs to be reinvented. Why this matters? As AI models grow from billions to trillions of parameters, the compute required isn't just more, it's exponentially more. Training costs, energy demands, cooling, interconnect bottlenecks, all skyrocket. Cerebras is positioning itself as the infrastructure company for that next generation. The company claims its inference, and training systems deliver performance that no number of GPUs can match. For companies building AI that demands speed, real-time responses, and massive scale, this hardware could be the difference between ambition and reality. Current landscape and competition. The AI hardware space is crowded. Nvidia dominates with GPUs. Others like GraphCore, Grok, Tenstorrent are innovating. Yet Cerebras is choosing a path less traveled. They're betting the future won't just be about faster GPUs. It will be about new architectures. And right now, they claim to hold the world speed record in AI inference and training. Cerebras. The challenge? Cost, manufacturing yield, customer adoption. Building wafer-scale chips is risky. The stakes are high. Real-world use cases. Some of Cerebras' customers include major research institutions and enterprises using their hardware for the most demanding AI workloads. They've helped accelerate drug discovery, genomic research, complex simulations. Contrary research. For example, a single Cerebras system might train a model in weeks that would take GPUs months. That speed matters. The cost savings and access matter even more. Future goals and vision. So where is Cerebras heading? Model scale explosion. As models grow, the need for hardware like this becomes more urgent. Inference at real-time speeds, not just training, but instant responses for AI in the field, on devices in data centers, for agents that act without delay. Edge and enterprise deployments, on-prem, cloud, hybrid. Their hardware is designed to be used in multiple settings. New architecture ecosystems. If they succeed, the AI world may shift from GPU-centric to wafer-scale systems, or even beyond, a new standard. The ambition is staggering. AI systems that reason at speed, agents that learn in real time, simulations that run at scale, once thought impossible. And behind it all is hardware, built for that future. Risks and what could go wrong. No giant chip without giant risk. Wafer-scale fabrication is expensive, yields are difficult. There's also competition, supply chain issues, and market adoption challenges. Reports suggest a heavy dependency on a few large customers. If the market moves slower than expected, or another architecture wins, the payoff could be delayed. But high risk often comes with high reward. Conclusion, Cerebras. Systems may not be a household name yet, but they might become the backbone of the next AI era. In a world dominated by GPUs, they chose a different path. One giant chip, one wafer, one future. As AI continues to expand, the hardware question becomes clear. How do we scale? How do we make AI not just bigger,